Hi everyone, my name is Palak and I am from group 322. Today we will talk about optical activity of biopolymers. Its definition states that optical activity refers to ability of biopolymers to rotate plane polarized light. There are some types of optical activity that includes circular dichromism, that says that difference in absorption of left and right circulatory polarized light. Optical rotatory dispersion, variation of optical rotation with wavelength. Circular polarization, emission of circularly polarized light. Biopolymers exhibiting optical activity. Proteins that have example of enzymes and antibodies. Nucleic acids, DNA and RNA, polysaccharides, for example glycolose and starch, glycoproteins, lipopolysaccharides. There are some factors that influence optical activity that includes molecular structure and conformation, celularity, solvent environment, temperature and concentration. There are some applications that are structure analysis of biopolymer, protein foldings and stability studies, DNA binding and gene regulation, glycoproteins analysis, biosensing and diagnostics. Measurement techniques are polarimetric, spectropolarimetric, optical rotatory dispersion spectroscopy, vibrational circular dichroism spectroscopy. Theoretical models include molecular orbital theory, density functional theory, molecular dynamics and stabilization. There is a common polymer materials for optical applications that are polymethyl methacrylate, acrylic, polycarbonate, polystyrene, and there is essential to be the carbon atom to be asymmetric in a compound. No element of symmetry in molecule. Otherwise, the optical activity of that particular molecule will not be shown. There are some equations that are specific rotation equation, where A stands for observed rotation, in degrees, L is path length, and C is concentration. Molecular optical rotation equations, where M is molecular optical rotation and the other M stands for molecular weight. These equations are fundamental to understand optical activity of biopolymers. Our other topic is magnetic optical activity. The definition states that magnetic optical activity refers to phenomena where magnetic fields influence optical activity of materials. There are some types that are magnetic circular dichroism, passes linearly polarized light through a material in a magnetic field parallel to the direction of magnetic field, and polarization plane is rotated. The second one is magnetic optical rotatory dispersion, variation of specific rotation of a medium with respect to wavelength of light. Third one is magnetic linear dichroism, passes linear polarized light through a material in magnetic field parallel to direction of magnetic and polarization plane is rotated. Phenomena: Faraday effect, rotation of plane polarized light. The second one is Zeeman effects, that is splitting of spectral lines. Third one is Gordon-Morton effect, birefringence. There are some theories that states that classical electromagnetism propagating light fields obey Maxwell's equations, under which electric and magnetic fields exchange their strength in an oscillatory manner. Second one is quantum mechanics field of physics, that explains how extremely small objects simultaneously have characteristics of both particles, tiny pieces of matter, and waves or disturbance or variation that transfers energy. Density functional theory, a quantum mechanical atomized simulation method to compute a wide variety of properties of almost any kind of atomic system, molecules, crystal surface, and even electronic devices when combined with non-equilibrium Green's functions. Applications include magnetic spectroscopy, biomolecular structure analysis, material science, magnetic fields sensors. There are some equations which include Faraday rotation, where there is Faraday rotation, variant constant, magnetic field, and conductivity. The second one is MCD intensity, where is MCD intensity, observation confidence plus helicity absorption, and coefficient minus helicity. Experimental techniques include magnetic circular dichroism spectroscopy, vibrational magnetic circular dichroism spectroscopy, and spectropolarimetry. That's all. Thank you. The summary is that optical activity occurs only in chiral materials, those lacking microscopic mirror symmetry. Unlike other sources of birefringence, which allow a beam state of polarization, optical activity can be observed in fluid. This can include gases or solutions of chiral molecules, such as sugars molecules with helical secondary structure as some proteins, and also chiral solids such as certain crystals with rotation between adjacent crystal planes or metamaterials. When looking at source of light, rotation of plane of polarization may be either to right or left depending on which stereoisomer is dominant. For instance, sucrose and camphor are derotatory, that means they have right direction, whereas crystol is allrotatory, that is left. For a given substance, angle by which polarization of light of specific wavelength is rotated is proportional to path length through material and proportional to its concentration. Optical activity is measured using a polarized source of an polarimeter. This is tool particularly used in the sugar industry to measure the sugar concentration of syrup, and generally in chemistry to measure the concentration of an anatomic ratio of chiral molecules in solutions. Modulation of a liquid crystal's optical activity viewed between two sheets polarizers is a principle of operation and liquid crystal displays used in most modern televisions and computer monitors. Dextrorotation and levo-rotation in chemistry and physics are the optical rotation of plane polarized light from the point of view of the observer. Dextrorotation refers to clockwise or right-handed rotation, and levo-rotation refers to counterclockwise or left-handed rotation. That I already mentioned have examples of camphor and cholesterol. A chemical compound that causes dextrorotation is dextrotary, while a compound that causes levo-rotation is levotric. Compounds with these properties consist of chiral molecules and are said to have optical activity. If chiral molecule is dextrorotary, its antinomer will be levotric, and vice versa. Anatomers rotate plane polarized light the same number of degrees but in opposite directions. Thank you.